No.
And the little topic on this, what does it say? I think it says multi-step equations. Yeah, multi-step equations. And multi-step equations would seem to look like this. There's really no way about it except writing one down here. So write this one down. 5x plus 8. 5x plus 8 minus 3x plus 2 equals 20. What do you suppose the first step you should do in any time you see like a long equation like that? Ultimately, well, yeah, Tyler.
Combine like terms.
Yeah, I will say it like this. First of all, you want to do is you want to simplify each side first. In other words, look at the equal sign. Think about what you got on the left side. Think about what you got on the right side. And see if there's stuff that you can put together. You want to get it down so there's just one number, one letter, as opposed to this, which has all much stuff. You can't do anything over here, so it's just going to stay over there. What can I put together on the left side, Carter A?
Negative 3x and 5x.
Yeah, which gives you
2x.
2 x's, and I can put together the 8 and the 2, which gives me 10. All right, and then once we get it there, it's really pretty much like any other one, but let's use some mathematical jargon here. What would be the next step? In math, we would say isolate the variable. And this one, you would add and subtract stuff from left to right. You want to get the letter by itself. Oops. And we always, in this case, remember, you always think backwards distributive property. What you're doing when you're solving the equation is you're actually, you have the answer kind of thing, but you're working backwards. So the first thing you always get rid of is the adding and subtracting stuff. I subtract 10 from both sides, which gives me, I'm left with my 2x over here. 2x equals 10. And then, generally speaking, children, the last step you're always going to do in the equation is you're going to divide to get x by itself. In step number 2, this is always adding and subtracting stuff. Step 3 is multiplying and dividing. So you divide by 2, you divide by 2, and x is going to equal 5. Now, if you were really a super mathematical sort of person, you would check your work by doing what? Putting that in for x and seeing if it all works. 5 times 5 is 25. Is 25 plus 8 minus 15 plus 2. If you do all that, do you get 20? I don't know. 25 plus 8 is 33. 33 minus 15 is 18. 18 plus 2 is 20. And you're guaranteed to get it right. Now, that obviously can't be the hardest one, can it? Who said no? Let's go right for the juggler. How about this one? 5x minus, in parentheses, x minus 3 minus 1 equals 18. And this is virtually or basically the same thing. You just got some other simplification stuff to go here. This is where people usually go wrong. What do I have to do first in this case to simplify the left side? Abram, what's the first thing I'm going to do? Get rid of the parentheses. How do I get rid of the parentheses? By somebody, what am I going to do? Parker? How am I going to do that? How do I get rid of them parentheses? Little thing I like to call the distributive property. What am I multiplying the stuff in the parentheses by?
5x.
I am not multiplying the stuff in the parentheses by 5x. I should heed, I headed, or heeded. What do you multiply by weight? Yeah, negative or negative one, you get the same thing. If you multiply 2 by this negative, what are you gonna get? Negative x and a plus 3. Changes it to opposite, changes it to its opposite. This still is here, this still is here. That still is there. Then you're still simplifying here, so I gotta combine what I can on the left side. Brant, what do I get if I combine stuff on this side? What is 5x minus x? Congratulations. And what is 3 minus 1, Brant? 2. And that equals 18, and then I'm kind of back where I was in that last one. Subtract my 2, subtract my 2, I get 16. 4 equals 16, divide by 4, divide by 4, x equals 4. Questions, problems, concerns. Here's where I address all of your needs. I am here for you. Do you not understand?
We're here for you too, Mr. Nunn.
Oh, Carter, that means so much to me. Look at page 155, will you please? Let me see if there's a good one in here. Look at all those words. Look at problem letter D. Juan is building a triangular shelf. He wants one angle to be a right angle and the other 2 angles to have the same measure. What are the measures of the angle? Now I know you know the answer to that, or probably don't need to do this, but you really should see if you can't use math to help you out here. I don't know what those 2 angles are here, but I know that one angle is 90 degrees. What would be your mathematical formula that would tell you, I mean, what equation would you write for that that would give you the answer to what x is? Let's see it in action. What do I know about all the angles of a triangle? They, Tyler? They equal 180. So what angles am I adding together? X plus 90. X plus 90. Which means if I'm solving that equation, I get x plus x is 2x plus 90 equals 180. Subtract your 90, subtract your 90. 2x now equals 90. Divide by 2. Divide by 2. X equals 485 degrees. And again, I know you probably could have looked at that and got the answer, but that doesn't negate the point that you really need. I mean, because sometimes they won't be that easy. What if it would have said one angle should be double the other angle? Well, then this would be 2x. And you now together would be 3x. That's easy. Shall we just move on? Shall we just have an assignment? Shall we just have fun, Dave? Wait. Let us also turn then to page 159. Because you don't need to take any notes on this. What is the title of this, Carter Westall?
Identifying misleading receptions of data.
Yes, the receptions of data. Or let's go with the representations of data. Take a look at, they're trying to get you to understand that sometimes, especially when people do advertisements or even political campaigns, you can certainly be deceived. For example, one of my favorite deceptions is when somebody says, you know, come to Valley Honda because we sell cars at a fraction of what our competitors do. Why is that misleading?
Because they wouldn't be in business.
No.
You don't know what fraction.
You don't have any idea what fraction it is. Let's say, what if the fraction, first of all, fraction of, right? Fraction of means to multiply. You know, what if at one dealership the car was $10,000, but the fraction that Valley sells it for is 8/5? What if their fraction is more than 1? How much are they going to sell the car for? Well, divide that to $16,000. Valley sells it for 16, but it's still a fraction of that. I mean, you just have to look at the wording. But this case here, you have to be careful. What is misleading about the first graph? It is the number of members at a health club. What is misleading? Look at that graph. When you look at that graph, what's your first thought? Has the membership increased like a lot? Now, why is that misleading? Well, the membership may have increased a lot. It may not be as big as you think. Why?
It's
Anybody?
over 6 months.
No, not necessarily over 6 months, but it's... Anybody, come on, work with me here, somebody. What's missing? See the little squiggly thing? You've got this graph here, and then right here they have this little squiggly thing, and this is 600, and this is 700, 800, 900. What's missing is the whole bottom 600 parts of this graph. In other words, this graph really, for it to be accurate, I have to redraw it. You know, you've got the top third, this is where it starts, you still have 2/3 more pieces down here. So the graph should look this big, and then the line, while it goes up, I mean, it doesn't go up as much as you think because you're missing half of the graph that would be the bigger portion of it. You know what I'm saying? Well, maybe you don't. Maybe you're just not 8th grade. Or how about the second one there? A radio station conducted a survey of music. The listeners, the bar graph shows the results. You know, what does that show you there? What's the problem?
They're all like the same.
They compare the quantity. It's like
Right. Each line stands for what? 500 listeners. So you have no idea. I mean, the difference between rock and other is how much? You can't even tell. What's the difference between rock and hip hop? I mean, it might be how many people though?
7.
It could be 80. All right, flip the page. You kids are killing me. Look at this. Let's just go to the practice over there. Look at that circle graph there. What is the problem with the circle graph? The circle graph, right there, read with me letter C. The circle graph below shows the number of kinds of dogs that were sold by the pet store. Explain why the graph may be misleading. Oh boy, now. Anybody? What could be wrong about that, Evelyn?
There's no time frame on it.
Not according to this. When you use a circle graph, what's the thing about circle graphs? Yeah. Circle graphs have to include everything. Now this doesn't say that those were the only types of dogs that were sold in the store. There could have been 50 other dogs that were sold that aren't on the graph. You know, bar graphs, if you're showing comparison, you should use bar graphs. If you're showing a whole thing, I mean, are the only kind of dogs that a store would sell would be poodles, retrievers, Dalmatians, and dachshunds? Probably not. Yeah, that's enough of that. No, I'm done. We're stopping at 27. What should we do with 27?
Your choice.
It is my choice. Ultimately.